All right, today we're going to look at day number 2 of chapter 6 notes. These are notes on inequalities. As we take a look at these notes here, I have a yellow box here highlighted at the top. You will probably want to write this on your notes as well. And the reminder here is that if you multiply or divide by a negative number, you have to remember to flip the inequality signs. This is a very important mathematical rule that we have to remember to follow. The examples we're going to look at today when we are solving are going to be situations where we have the variable on both sides of the equation. We're going to have some special case scenarios, which we'll talk about when we get there. But I'm going to start out here with problem number 1. And problem number 1, I'm going to move to the side that has more. And I'm going to move them to the left side because on a number line, negative 3x is actually larger than negative 5x. I know both of those are negative numbers. But if you think about that on a number line, negative 3x is actually larger. It's further to the right on the number line than negative 5x. When I do this, I'm going to get 10 plus 2x is less than 4. I'm going to subtract 10 on both sides. I'm going to get 2x is less than negative 6. I'm going to divide by 2 on both sides and get x is less than negative 3. Again, I did not need to flip that inequality sign because I was dividing by positive 2. Even though the numerator was negative 6, the number that I divided by was positive 2. I'm going to get x here is less than negative 3, so I'm going to put an open circle at negative 3. We're not going to include that as a solution. And the solutions that work are all these numbers that are smaller, or what we talk about as more negative than negative 3. In problem number 2, I need to worry about the distributive property first. So I'm going to distribute on both sides. I'm going to get negative 3x, this is plus 4, is greater than or equal to 6x plus 4. I'm going to move to the side that has more, so I'm going to add 3x to both sides. I'm going to get 4 is greater than or equal to 9x plus 4. I'm going to subtract 4 on both sides. 4 minus 4 will be 0 is greater than or equal to 9x. I'm going to divide by 9. I'm going to get 0 is greater than or equal to x. Because 0 divided by 9 is 0. Please note here, though, what I have stated is that 0 is greater than or equal to x. Another way I can write that, I'm going to put this over here on the side and say, or I can say that x, if I read this from right to left, is less than or equal to 0. Again, I'm going to put that in parentheses, though this was my initial solving. What I again want to do is I want to recognize where 0 is, and I want to be graphing all those numbers. If 0 is bigger than all the other numbers, then what I need to do is put a closed circle at 0 because 0 is an included solution, and then highlight all those numbers or shade all those numbers that would be smaller than 0. Because remember we said 0 is the larger. Again, if you wrote your inequality as this one over here, that is also equivalent. It's just a matter what side of the inequality sign your variable lies on. When I go to problem number 3, in problem number 3, I'm going to deal with some combining like terms on the left side first. I'm going to work to put the y's on the same side, so I'm going to add 4y to both sides. And when I do this, the y's cancel out on the left side. They also have to happen to cancel out on the right side. So what I'm going to get here is 0 is greater than or equal to 5, but this is a false statement. Because this is a false statement, our conclusion here is that there are no real solutions. Or some people will just say no solutions, period. If you would like to graph no solutions, here is your number line. And as you can guess, if there's not any solutions, there would be nothing that is shaded. What I want to talk about real quickly here is this part here. And we saw this back in chapter 3 when we were talking about solving equations and what happened when both variables dropped out. So I made a little note here on this extra page that we had for our notes, and it was special cases when solving equations and inequalities. And what I wanted to recognize is that if we get a false statement when the variable has been eliminated or drops out, that is a situation where we get no solutions. An example of this would be like what we just saw up there, or here I wrote 6 is less than negative 2. That is not any different than when we were solving equations back in chapter 3, and we ended up with something like, does 3 equal negative 4? Well, we know that 3 doesn't equal -4, which is why we talked about this as no solution. And what that means is that there's no number you could plug in for x that would make that true. If I look at the other case, which is going to be what happens if I were to get a true statement when the variable has been eliminated, which means you cannot solve for the variable, then we'd end up with all real numbers. And what this means is, again, I'm going to reference here back to chapter 3. If I was solving something like this problem here, and I do the distributive property, and I get 3x plus 9 equals 3x plus 9. If I subtract 3x on both sides, that is good. The variables cancel out on the left, the variables cancel out on the right, and I get 9 equals 9. Well, what we know about 9 equals 9 is that that is always true. The number 9 is always going to be equal to or worth the same value as the number 9. So the solution to this then would be all real numbers. And the real reason it is all real numbers is what this is saying is that it doesn't matter what number I plug in here for x, whether or not I plug in 0, whether or not I plug in -10 or +2. If I were to evaluate this, I would always end up with something on the left being equal to something on the right. Again, I'll say that one more time. What all real numbers means is that no matter what I plug in here for x, let's say I plug 10 in, I'd get 10 plus 3 is 13. 13 times 3 would be 39. If I plug 10 in on the right side, we're going to say if we also get 39, and that would be 3 times 10 is 30, plus 9, which again is 39. I could plug in something like -2, and if I plugged in -2, I would find out that what I get on the left would also be equal to what I get on the right. So it doesn't matter what number you're plugging in, every possible number out there would work. So again, if you like, you can copy that down on that extra page. Otherwise, that was just a quick review of what we learned back in chapter 3 and how it relates to inequalities here in chapter 6. As I look at problem number 4, I'm going to continue on with the distributive property on the left side. On the right side, I have some x's I can combine. 6x minus 2x is going to be 4x. At this point here, I still have variables on both sides, so I'm going to subtract 4x to get the variables on the same side. But as I do that, I get -12 is less than or equal to 5. Well, we know -12 is not equal to 5, but we do know that -12 is less than 5. If you think about that, that is a true statement. So again, when we get this true statement, we get all real numbers as our solutions. And again, what that means is that any number I plug in there for x at the start, to the original up here, would result in a true statement. How do you graph this? Well, I'm going to put my number line down here at the bottom, but now just not highlighting anything, I'm going to highlight everything. I'm going to highlight those negative numbers. I'm going to highlight those positive numbers. I'm going to highlight those decimals, those fractions, those integers, every possible number that would be on this number line, continuing on forever. Throw some arrows on the end to show that it keeps going. As I look at problem number 5 says, write and solve an inequality to find x. Well, this problem here talks about finding the area of a rectangle. And it tells you that the area is going to be greater than 50. So we have to first go back and review that we know that area is going to be related to length times width. That's the area of a rectangle. What we know here is that the area is greater than 50. So I'm going to write 50 as my area is greater than the length times the width. In this case, it's going to be 4 is my length, and my width here is x plus 5. The most important thing is here we have to be able to set up an inequality. So we know that the area is greater than 50. And let me pause here because the area of this rectangle is greater than 50. It doesn't say 50 is greater than the area, so I actually need to be careful here on this inequality and say that if I said the area of my rectangle, this might be an easier way to think about it, is that my length times my width has to be greater than 50. And again, sometimes it's easier, instead of setting this up as area equals length times width, in a situation like this, it might be easier to set this up as length times width equals the area. But again, both these are equivalent. It's just a matter of what side the 50 is on. Here I put the 50 on the right side of the inequality. Here I put the 50 on the left side. But in both cases, this inequality sign is eating the part that is larger, which is the area. So I'm going to distribute on the left side. I'm going to subtract 20. 4x is going to be greater than 30. I'm going to divide by 4. And I'm going to get x is greater than, this is 30 divided by 4, which is 7.5. This is my solution. It also says, right in solve the inequality, it does not ask us here to graph this on a number line, but what this is telling me is that if I wanted to pick values for x that would make this area larger than 50, I would have to have something like not 7.5, because that would be equal to 50. We want it greater than 50, so maybe something like 7.6, something like 10. If I check 10 here, I would get 10 plus 5 is 15, and 15 times 4 would give me an area of 60, which is bigger than 50. So I can say that I just did a quick little mental check to verify that would work, and yes, something like 10 would in fact be giving me an area that's bigger than 50. And again, that here is a wrap on day number 2 notes. Next up, you'll be working on day 2 classwork. Have a good day.